Okay, I'm presenting the paper Person Re-Identification using multiple first-person views on wearable devices on behalf of the authors at NTU Singapore, A-Star Singapore, and IIT Geneva. So the problem that we're dealing with is to try and re-identify and track one or more targets over multiple non-overlapping camera fields of views. Existing systems that use this, particularly security systems, struggle with a number of problems including low resolution, occlusion, and wide viewpoint, which make it very hard to extract robust discriminative features for recognition and re-identification. So we really wanted to ask the question, do first-person view videos from wearable cameras offer a possible solution to this problem? With cameras like Google Glass or GoPro, it's possible to capture unoccluded, high-resolution face shots, which we can then use for re-identification. We can also place these anywhere in a crowded location to obtain clearer views. So in this vein, we wanted to propose a two-step first-person video re-identification pipeline. In the first step, we want to compute the features from acquired first-person view images, and then calculate similarity scores between all pairs of observations in the devices. In the second step, we then take these computed scores and use them as inputs to a global data association method to estimate network consistent features and final association labels across these two devices. So what we found worked best was the whole space subclass discriminant analysis for feature extraction. In this method, images are normalized, and then each class or people are divided into subclasses using spatial partition trees, which kind of helps capture interpersonal variations arising between the appearances of the same individuals. We also use discriminant analysis and eigenfeatures to do the same. We then use these regularized features and compute scatter matrices, and then use dimensionality reduction and discriminant evaluation to extract features. Overall, what this allows us to do is take incoming face image vectors and convert them into feature vectors using a learned transformation matrix. We then take these feature vectors and compute a cosine distance with nearest neighbor to generate pairwise similarity scores in the first step of our pipeline. In the second step, we deal with data association approaches. So most data association approaches work on pairs of point data sets, and then on a network of data point sets, you get both direct and indirect associations between pairs of people. What this leads to is network inconsistencies when the direct associations and indirect associations are unable to match or don't match up. To deal with this, the authors proposed a method, network consistent re-identification, which is an optimization framework for combining pairwise data association results. NCR establishes global consistency as well as increases the intrinsic pairwise data association as well. There's not a lot of research that's been done with first-person view person re-identification problems, and so to test this, we actually created a database of FPV videos with 72 people and 4 wearable cameras. So not all of the people were observed in all of the cameras, and these databases or images were labeled for person re-identification. As a baseline, we used PCA, Fisher faces, and WSSDA to compute a baseline result, and then we passed these through our pipeline as well. As you can see with the main rank, low rank scores, our pipeline method performs far better than the baseline in low rank. Overall, WSSDA plus NCR is the overall winner. And if you have any additional questions, you can ask me at our poster 3A4. Thank you very much.